Let's enlarge our C repertoire with resize. In resize, we're given an in-file bitmap, and our job is to create an out file that scales that bitmap by n, a user-given number. Okay, so let's break this down. Today we'll talk about how to open the in file, then create an out file and update that out file's header information. Then we'll read into the in-file scanline pixel by pixel, resizing horizontally as we go. It's going to be really important to talk about padding and understand exactly where to put it in and when to skip over it. Finally, we'll talk about resizing the file vertically as well. Now this is a lot to do, but luckily we have a good starting point because copy.c actually implements a lot of this functionality. Copy.c will open a file, update the header information, then it will read each scanline pixel by pixel from the in file and then write those pixels into the out file scanline. So even though it doesn't necessarily resize the file for us, it's a great place to start. So let's copy the code from copy.c into resize.c. All right, so now that we've done that, we want to update the out file's header information. So let's talk about bitmaps for a sec. Bitmaps are simply an arrangement of bytes, just like any other file you'll encounter. It's just a matter of how we interpret this arrangement of bytes. So take a peek inside bmp.h for more information. With a resized bitmap, we'll have an updated header. So what's changing in the header? Well, our file size is changing, our image size, and of course, the width and height of our file. So what are those variables exactly? Well, within the bitmap info header, we have bi width, which indicates the width of the image in pixels, not including padding. More on padding in a sec. Then we also have bi height, which represents the height of the image in pixels. Last in the bitmap info header, we have the bi size image, which is the total size of the image in bytes, including pixels and padding. Then we move to the bitmap file header, where bf size includes the total size of the file in bytes. So this includes pixels, padding, and the headers. So the bf size can be calculated by adding the size of the image from the bitmap info header and adding that to the size of those headers in bytes. Okay, so when we scale the image by n, what's changing? Well, pretty obviously the width and the height are both going to be scaled by n. But what's happening to bi size image and bf size? Up to you to figure that out. So now that we've dealt with the header, let's start looking at the pixels. So to read into the in-file scanline, copy.c calls the function fread, which takes in 4 parameters. The first is a pointer to the struct that will contain the bytes that you're reading, and then the size of each element to read, then the number of those elements to read, followed by the file pointer that you want to read those from. So now that we know how to read into the scanline for the in file, let's talk about resizing. We're going to tackle resizing horizontally first. For this, essentially what we need to do is for each pixel in the row, we want to write it n times. So for an n of 2, I'll go to my orange pixel and write that twice, then proceed to my red pixel, write that twice, and finally my blue pixel I'll write twice as well. We call upon the function fwrite to write those pixels into our out file. Fwrite takes in 4 parameters: the pointer to the struct that contains the bytes you're reading from, then the size and number of the elements you want to write, and finally, the destination of those files as a file pointer. Now that we've talked about resizing horizontally, it's time to get to the padding. In a bitmap, each pixel is represented with 3 bytes. Now the length of each scanline of a bitmap must be a multiple of 4 bytes. Now if the number of pixels is not a multiple of 4, then we'll need to include padding, where padding is just zeros. Here's an example where I have 4 RGB triples. Each triple is comprised of 3 bytes, so 4 triples, 3 bytes each, that's equal to 12 bytes. Because that's a multiple of 4, I don't need any padding. Now say I have 5 RGB triples. 5 triples times 3 bytes each equals 15, not a multiple of 4. So I need to add 1 unit of padding in order to reach a multiple of 4 bytes. If I have, say, 6 triples, then I'll need to add padding as well, but a different amount than last time, in this case, 2 zeros. Finally, in this example, if I have 3 triples, then 3 times 3 is 9. So in order to bump it up, I need to add 3 units of padding. It's really important to understand the concept of padding. Don't worry about the equation, I've provided it here, and you can also find it in the problem specification. You'll notice that the padding takes into account the size of an RGB triple as well as the width of the image in pixels, found in the BI header. Because we're resizing the out file and the in file will have different widths, so the padding will most likely be different. The other important fact to remember is that padding isn't an RGB triple, so we won't be f-reading or f-writing it in. Instead, to write padding, we'll use the fputc function, which takes in a character to write and then the file pointer to write it to. So in this case, we'll be putting in a 0 for the padding into our out file. Let's look at an example using n equals 2 for simplicity. At the first pixel, we'll resize horizontally, so we'll write that twice into the out file. Moving on to the second triple, we'll also write that twice, resizing horizontally. Now you'll notice here that while the in file requires padding, the out file doesn't. The in file only has 2 pixels, which results in 6 bytes, so it needs 2 units of padding to reach a multiple of 4 bytes for the scan line, whereas the out file has 4 triples, so that results in a multiple of 4 bytes for that scan line without needing any padding. The key takeaway here is that the padding may very well be different from the in file to the out file. Looking back to the equation for padding, we know that this depends on the BI width. But recall from earlier, we know that BI width is going to be changing from the old to the new. So perhaps we need to calculate how the padding is going to change, but also keep track of both the old and the new padding. With that said, let's go back to some pseudocode. Now this is pseudocode just for resizing horizontally. It's not going to be the final algorithm for your entire problem. But to resize horizontally for each row and for each pixel in the row, we want to write to the out file n times. Then we want to write the out file's padding once we've finished that row, but then skip over the in file's padding so that we reach the next row in the in file. Try to see if you can implement resize by simply stretching by n horizontally first. Then we can move on to resizing vertically. In resize, every pixel is repeated n times. That's the horizontal resizing component. But then every row is also repeated n times. So say I have an n of 3 and a single pixel. Then that pixel is going to be repeated 3 times in a row. Then that row is going to be repeated 3 times as well. Alright, so now let's move on to a more complex example with more than 1 pixel needed to resize. I'll go to my first pixel and write that twice, then go to the next, write that twice, and then the third, write that twice. We've already achieved this by resizing horizontally. Resizing vertically entails repeating that process another time so that we've repeated the row twice. Only then will we move on to the next row in the in file and repeat that same process. There are 2 overarching methods in which you can resize vertically, and even within those methods there are multiple options for implementation. So the first type of method is a rewrite method, in which you remember the pixels that need to be written in the array and then write that array as many times as needed. Or there's the recopy method, in which you go back to the start of the original scan line and recopy that line as necessary. I've mentioned a couple times now seeking back or skipping forward padding, lines, etc. What I mean by this is that we need to move the file position indicator. The file position indicator is essentially a cursor. Whenever you f-read into a file, there is a cursor that keeps track of where you are in that file. If you ever want to move that, then you call upon fseek, which takes in the file pointer that you're seeking in, the number of bytes that you want to move the cursor, and then finally, whether or not you want to move relative to the current position in the file, the beginning of the file, or the end. Now that you're equipped with fseek, we can talk about pseudocode for the rewrite method. Now remember that even within the rewrite method, there are multiple ways to implement this. So your pseudocode and your implementation might very well be different than mine, and that's okay, as long as it works and the basic premise is the same. That for each row, we're going to make a copy of the array that we want to write. Then, for n times, we'll write that array to the out file and write the out file padding. Once we're done, we'll fseek over the in-file padding and then repeat for the next row. Now we come to the recopy method. In the recopy method, the in-file cursor starts at the beginning of a row. Then for n-1 times, we'll want to write the pixels scaling horizontally to the outfile and adding the padding to the outfile as necessary. Then, once we've written that, we'll send the in-file cursor back to the beginning of the row and repeat that process. After we've done that n-1 times, then we'll write the pixels once more, scaling horizontally, adding padding to the outfile. Only then will we skip over the in-file padding, bringing us to the next row, ready to repeat the process. We're in the home stretch, so let's just wrap up and summarize and make sure that we're on the same page. We want to open the in-file and create an out-file, updating the out-file's header information appropriately and keeping track of whichever variables we need to from the in-file. Then we'll read into the in-file scanline pixel by pixel, resizing horizontally, remembering to add padding, and resizing vertically. Now, I admit, my own code didn't work perfectly the first time that I tried resize, and yours might not either. So, if that happens, make sure to put pen to paper, draw out your pixels, perhaps a simple smiley, or just a box, and follow through your own code to make sure that the logic works, and you might find your bug that way. Good luck! My name is Zamila, and this was Resize.